A very warm, sunny good morning to one and all. Um, it's indeed my privilege to host this guest lecture today. And indeed, I'm very much honored in welcoming Dr. D.B.Rana, sir, from SB Jain College, Nagpur. Let me introduce you, the very loving and very caring one of the faculty of chemistry. Dr. Dilip Kumar Rana sir is having teaching experience of 17 years, which includes 13 years in engineering and 2 years in science college. Presently, he is working as an associate professor in SB Jain Institute of Technology, Management and Research, Nagpur. He has served as environmental analyst in environmental division of Ambuja Cement Private Limited, Chandrapur, Maharashtra. He has also worked as R&D chemist in a drug manufacturing unit in Chandrapur, Maharashtra. Sir's specialization is physical chemistry and he loves environmental chemistry as well. His PhD work in grey water, that is domestic wastewater treatment, has won national and international prizes. His portable grey water system has been awarded by a copyright by Government of India. Indeed, sir, it is our honor to have you today as a guest lecturer. And I feel my student is going to love to be a part of this guest lecture. Now, may I hand over the studio to sir to kindly proceed with his guest lecture. Over to you, sir.
Thank you so much, ma'am. Uh, uh, Tasneem ma'am is one of the senior faculty, and when she conveyed me to have this lecture yesterday itself, I was very happy because ma'am is always a caring faculty. She taught us very good things, and I learned a lot from her as a teacher. Thank you so much for your very nice introduction. I'm not so much great to have that
No,
introduction, but
sir. It's
it's
not
it's a
like that.
great
You are
privilege
one
to
of the
be here
wonderful
with you.
faculty.
Okay, ma'am. Can I share my screen, ma'am?
Yes, sir, it's already there.
Is it visible?
Yes, sir, it's visible.
So, a very warm good morning to all the student, ma'am, HOD sir, and the institute fraternity. As you can see on the screen, I am going to discuss the thermodynamics function, and there is one ice cream melting there. Now, this ice cream is melting, and we will see how the things been studied with respect to our day-to-day life experiences, because we cannot escape any process uh, without considering the thermodynamics. So as a token of love, I am sharing this ice cream with you all, and this is melting. Let us have the experience of beautiful thermodynamics in the science as well as in our life. So these are the content that we are going to discuss in this guest lecture series. The first lecture, the brief introduction of systems surrounding boundary, extensive and the intensive property. Then thermodynamic functions, energy, entropy, free energy, definitions, basic equation of internal energy and enthalpy. Second law of thermodynamics, reversible, irreversible process, and role of Gibbs free energy. Now, this is the syllabus of unit number 2, and uh, it almost cover a streamline of the thermodynamics, and we will take one by one point with this uh, content. Now, what are the terminologies we generally use in the thermodynamics? So dear student, you must have learned these things in your 11th and 12th. Because when we learn thermodynamics is a dynamics due to the thermal, dynamics due to the temperature. Because whenever a system is being run with certain processes, it changes with the temperature. So when there is a transition in the system, or there is a transformation from one form to another form, there plays an important role of temperature. And this is being studied with the physical chemistry area, that is a thermodynamics. There are few basic things. I think the language is comfortable, I will definitely go with the different uh, languages with respect to the consent of the student. Basic terminologies we use are the system and the surrounding. Now whenever we see this system and the surrounding, these are the area that we learn with respect to its processes. For example, you may have uh, been with the titrations in your 12th standard as well as the hardness titration in the first year. Now this conical flask for us is a system. Okay, and whatever the chemical we take are the components. And when we study this titration and we are in the laboratory becomes the surrounding, and the surrounding is in the universe. So a system, a portion of universe under the consideration or the study is called as system. Means for the titration when we are taking the solution, it is the system for us, and this is a part of universe. And the portion of universe for the system which is under the study, the surrounding, means for the titration we are titrating the thing in the laboratory, then surrounding becomes our laboratory. Now, these are separated by certain boundaries. Obviously, the boundaries plays an important role. Now, we can give an number of example for that case. For example, if you are playing a cricket in a ground, okay, if you are playing cricket in a ground, then the ground becomes a system, then stadium becomes the surrounding, and the universe apart from system and surrounding is the universe. Means a system where actual processes takes place, surrounding in the place where system is there, and the universe surround the system and surrounding. Now this surrounding and the system is separated by certain boundaries, and these boundaries plays a major important role. Let us have certain diagrammatic representation. So this is the diagrammatic representation how systems surrounding an universe can be explained. The system is a central part where the process is being studied. It is placed in the surrounding, which is separated by the boundary, and the system and the surrounding is a small part of universe in a large domain. So basically, whenever a process is being studied, it is in the system, and this system is in the surrounding, and the universe is the main domain where system and surrounding takes place. So as I suggested, the conical flask as an example, I can take the another example, that is a beaker. Now, if there is a beaker, okay, and it is been filled with certain chemical, for example, NaOH, then this beaker becomes our system. This beaker becomes our system. Then the titration or the beaker or the apparatus what we use is in the laboratory. Then this laboratory becomes our surrounding, and they are separated by certain boundary, and this is the complete universe. So here we can conclude here that for studying any thermodynamic function we need three things. One is system, one is surrounding, one is universe. System is the smallest part, it is in the surrounding, and surrounding and system is in the universe, and this system and surrounding are separated by the boundary. Now somebody may ask here, sir, why this boundary, or what is the role of boundary in deciding the nature of a system? This boundaries plays important role. Now you can relate this with these two simple things that we use in the day to life. हम लोग इससे रिलेट कर सकते हैं कि किसी भी सिस्टम के लिए बाउंड्रीज किस तरह से एक मेजर रोल प्ले करती है. For example, the one is the thermos and one is a bottle, a metal bottle. Both plays important role in containing the solution, containing whatever we want. Whatever it is, a coffee, it may be milk, it may be tea, but both are having their own advantages due to their own property. For example, these are of adiabatic wall. The boundary in this case is called as the adiabatic wall. What it means, it do not allow mass and the energy transfer. Means if you keep certain solutions in the thermos, there is no change of temperature as well as the mass or the concentration with the surrounding. Means a complete separation between the system and the surrounding. But when a metal bottle or a plastic bottle is, it is a dithermal in wall, where mass is not allowed, but energy can be transferred. So that you can found that when you keep water, a cold water, in metal flask or the plastic flask, it gradually decreases its temperature. Why? The heat transfer takes place due to the atmospheric temperature. The cooled water becomes warm. That's why its temperature rises. But this has not happened with the thermos, because it completely restricts the entry of energy from the system to the surrounding or vice versa, and there is no chance of transferring the mass. So this boundary walls plays an important role. Now, depending on the boundary wall, we may have different systems. Okay, means isolated system, adiabatic system, isobaric system. These are the system that we involve in our laboratory experiment. If we take the example of titration, conical flask titration. Now this conical flask is being taken by certain solution, okay, and we titrate with the help of the burette. Now this solution that we keep in the conical flask have the chance of transferring the mass and transferring the energy, but the transferring the mass is not possible because glass do not allow solutions to come out, but energy transfer takes place. So I can consider this glass as a dithermal wall. I can consider this wall as a dithermal wall. Accordingly, I can have various systems: isolated system, adiabatic system, isobaric system, because this depends how the energy and mass is being exchanged between the system and the surrounding. Suppose there is a change of energy with the system surrounding, okay, and the mass remains same. That means there is a transfer of the energy from the system or from the surrounding to the system. There is a exchange of energy between themselves. But suppose there is a no mass change and there is no energy change between the system and surrounding, it is called as the isolated system, जहाँ पे हम लोग मास और ये नहीं देखते हैं, मास और एनर्जी ट्रांसफर नहीं देखते हैं. फिर कुछ सिस्टम्स ऐसी होती है जहाँ पे हम लोग जो प्रेशर कंपोनेंट है उसको कांस्टेंट रखते हैं. ओके, दैट इज कॉल्ड एज आइसोबैरिक सिस्टम. और अगर हम लोग वॉल्यूम कांस्टेंट रखते हैं, दैट इज आइसोकोरिक सिस्टम. सो दीज आर द वेरियस टाइप्स ऑफ द सिस्टम एंड दे आर डिसाइडेड बाय द बाउंड्रीज एज एन इम्पोर्टेंट रोल. Next one is macroscopic property of the system. Now as the word macroscopic comes from the term macro, means a larger one, means a system which is larger with respect to the mass as well as space are the macroscopic system. For example, if I consider 100 meter cube of a gas, 100 meter cube is a lot of system volume and the space. So when we study 100 meter cube of the gas, uh, that means it is it is of it is of uh, a larger domain. Okay, and I'm visible. Tasneem ma'am, I'm visible.
Yes, sir, you are visible.
Okay.
Yes.
In between, let me convey that I am visible and audible, ma'am. Okay.
Yes, sir, sure.
Okay. Now, this macroscopic system are the system where we study a larger volume and the space and the mass. Suppose, for example, 100 meter cube of a gas is being studied. Then it is called as the macroscopic system. And the property of the macroscopic system are of having two different types. Uh, that can be considered as a property which depends on the mass, and the property which do not depends on the mass. Means there are few types of the properties depending on the factor mass they varies. Okay, for example, अगर हम लोग देखते हैं कि हमने 1 kg शुगर लिया, if we take 1 kg of the sugar and if we take 10 kg of the sugar, 10 kg of sugar and 20 10 1 kg and 10 kg of sugar, the mass are different. Then the mass is the microscopic property which depends, and it gives a lot of effect on the property. But what about the taste of the sugar? If we taste sugar of 1 kg of sugar and 10 kg of sugar, is there will be change of the taste of sugar? क्या वो 1 kg के लिए स्वीट होगा और 10 kg के लिए वो बिटर होगा? No. So taste do not depends on the mass, but weight depend on the mass. So depending on the criteria, how the property vary with the mass, we have different types of the microscopic property, like pressure, volume, temperature, surface tension, viscosity, density. These are examples of macroscope property. Pressure, वॉल्यूम, टेम्परेचर, ये यानी हम लोग देखते हैं कि ये प्रॉपर्टी डिफाइन करती है उस सिस्टम के लिए, और इसको हम लोग फिर दो कैटेगरीज में डिवाइड करते हैं. द माइक्रोस्कोपिक प्रॉपर्टी और ऑब्जर्व प्रॉपर्टी कैन बी कैटेगराइज्ड इनटू टू टाइप्स. The one intensive property and other is an extensive property. Keep the example of 1 kg sugar and 10 kg sugar with yourself to understand what is intensive and what is extensive property. Now, extensive property. Those property whose value depend on quantity of substance present in the system are called as the extensive property. For example, mass means 1 kg of sugar, 10 kg of sugar. The mass is different. If the property varies with the mass, it is the extensive property, and one of the basic is the mass. Then next one, intensive property. Those property whose value does not depend on the quantity of substance present in the temperature present in the system is called as intensive property. इसका मास के ऊपर कोई रिलेशन नहीं होता. Okay, now as we have taken the example of 1 kg sugar and 10 kg of sugar, the mass varies. Okay, the weight varies. You will pay 10 times more cost for the 10 kg of sugar and unit quantity for the 1 kg of sugar, but taste remains same. If you taste for 1 kg of sugar, it will taste sweet. If we taste 10 kg of sugar, it will taste sweet. Similarly, the temperature. Okay, similarly the temperature. Boiling point of 100 ml water is 100 degrees Celsius, and boiling point of 1 gallon of water is also 100 degrees Celsius. So temperature becomes intensive property. Now there is certain list to identify what are the extensive property and the intensive property. Now what about if we take a ratio of these two? Or if we take two different types of extensive property, can it be converted to certain intensive property? Let's twist it around. For example, volume is extensive property. Again, it depends on the substance present. Volume of 10 molecule will be different, volume of 100 molecule will be different. Similarly, mass is an extensive property. Volume of 10 molecule, mass of 10 molecule will be different, and mass of 100 molecule will be different. But if I take the ratio of this, means if I calculate the density, mass upon volume, this is a constant for certain molecule, this is a constant for certain chemical, this is constant for certain mass, this becomes intensive. So how to understand this? If a property do not changes with the mass, it is intensive. If the property changes with the quantity of the material, it is the extensive. Now let us have the list of intensive and the extensive property. These are the examples of extensive and the intensive property: mass, volume, surface area, energy, enthalpy, entropy, free energy are the example of extensive property, because it depends on the quantity of the component present in the system, whereas temperature, pressure, viscosity, surface tension, dielectric constant, specific heat, vapor pressure, these are these are intensive property because they do not depend on the quantity of the matter present, and these are called as the intensive property. Now thermodynamic function. Why we are studying this thermodynamic function? Why it is required to have the information regarding the systems? Why it is important to have the information regarding the extensive and the intensive property? Because when we study a thermodynamic or a process, there involves two important parameters. One is a chemical phenomena or the chemical transformation, and one is the physical transformation. These are interrelated. We cannot take one single separately or without taking the consideration of other. They are not independent, they are dependent. Means if you want to study the chemical transformation, there is a significance with respect to its physical transformation. तिथे असेल नाही तुम्ही शोधून देतो ते क्लास चालू आहे माझा okay, sorry for the interruption. So basically the functions, thermodynamic function, which consider the the system, then different intensive extensive property and its transition with respect to uh, the process is called as thermodynamic functions. As the word come function, they changes, they have certain dependency on certain parameters. For example, if we use a process and to improve its pace, to improve its rate of reaction, we add certain material we can call it as a catalyst. Now, as we add the catalyst, the rate of reaction increases. Rate of reaction increases means the reaction which we, which is supposed to take more time will conclude in the lesser time. Means it is a function dependent, it is a time dependent. Means catalyst decreases the time for completing the reaction. Similarly, in the thermodynamic there are functions which decides the flow of the process, which decides the thermodynamic flow of the process. These are energy, free energy, and the entropy. So let's take first energy. In mechanics, energy can be defined as capacity to do work. Okay. For example, you have taken you may have taken a good healthy breakfast, beautifully cooked by your parent, your mother, and you take this breakfast and come to the class with lot of energy. Now this energy is important to do the work. Now this work can be of different types or energy of different types. Broadly, there are two different fundamental types. One is potential and one is kinetic. The potential energy is stored because of its position, and kinetic energy is due to the motion. Means if after taking the breakfast you are sitting in a class attending the class, okay, then whatever the focus you are having is the potential. With greater energy you are understanding the thing, it is a position. If you are sitting at the second floor in the classroom, your potential energy will be different. If you are sitting at the third, potential energy will be different. It doesn't relate it with the focus in which you are learning the thing, it is depending on the positions where you sit. Similarly, when you walk around, you will have certain energy, and this energy are nothing but the kinetic energy. Okay, now this is the simple justification of kinetic energy and the potential energy. As you can see here, this this vehicle reaches the top of the bridge, it achieves certain potential energy, and when it comes down due to the effect of gravity, it converts to the kinetic energy. Means the energy due to the position is the potential energy. The energy due to the motion is called as the kinetic energy. Now, with respect to our macroscopic system as a thermodynamics, we can have these categories as external energy and internal energy. Because with respect to the मैक्रो साइंस, अगर हम लोग वहाँ पे क्रेजी कैसल में जाते हैं या फन एंड फूड विलेज में जाते हैं, वहाँ पे डिफरेंट डिफरेंट एडवांटेज एक्टिविटीज़ होती है, तो वहाँ पे आपको काइनेटिक एनर्जी और पोटेंशियल एनर्जी का मेजर रोल लेते हुए दिखता है. दिस आर कॉल्ड एज एक्सटर्नल एनर्जी. बट व्हेन वी कंसीडर अ केमिकल चेंज, बट व्हेन वी कंसीडर अ केमिकल रिएक्शन, बट व्हेन वी कंसीडर अ टाइट्रेशन, this kinetic energy and the potential energy do not have so much of uh, interaction, rather dependency or the relation with the molecular forces of the chemical changes, because these are having a different nature, and chemical changes do not have a direct relation with them. That's why external energy are of little importance with respect to the chemical changes. But what is important here? The internal energy or intrinsic energy. This internal energy and intrinsic energy plays a major role, plays a major role in deciding how the course, how the process flows. And this internal energy depends on various thermodynamic parameters that we will take as the topics goes around. Internal energy most important in the thermodynamics because it decides the behavior of that system. Now, how did you decide the behavior of the system? With respect to its rotation, with respect to vibration, with respect to the translation motion of the molecule. See, even if a molecule is present at a low energy, अगर एक मॉलिक्यूल लो एनर्जी में भी है, उसमें रोटेशनल वाइब्रेशन एनर्जी होता है. फॉर एग्जांपल, जैसे कि हमारे एक स्टूडेंट ने यहाँ पे लीव एप्लीकेशन ला के दिया है एज ही वाज नॉट वेल यस्टरडे. तो यहाँ पे एक एप्लीकेशन दिया है, इट इज़ अ पीस ऑफ पेपर. नाउ इफ समबडी आस्क दैट whether the molecule on the piece of paper are moving or not. As the naked eye, if I observe, I will not observe a motion of the atoms or the molecules of the paper. But at molecular level, every molecule rotate, vibrate, and they translate, and this gives a energy to that system. Now somebody may think here, sir, how? हम लोग तो ये देख नहीं सकते हैं, तो इसको हम लोग आइडेंटिफाई कैसे करें? ओके, तो जब हम लोग इस पेपर को टेम्परेचर देते हैं, ओके, व्हेन वी गिव सम इग्निशन टू दिस पेपर, the paper burns, and when paper burns, the number of collision or the vibration between the molecule increases, due to which they converts to the next stage, liquid, and if the temperature rises, it goes to the gaseous state, and you will observe that the paper gives fumes. These are nothing but the molecule, and these molecules were stationary at the normal temperature. But as the temperature of the system increases, you will see this in a actual motion, and this is the relation how temperature plays important role in the internal energy. All types of energy associated with the internal energy, which involves electron proton mutual attraction repulsion, constitutes an energy. Means if a matter is there and it is having n number of atom and molecule, whatever the motions, whatever the interaction, whatever the relation, attraction, repulsion between them leads to the energy of that system, and this total energy is called as the internal energy, and it is denoted by E, sometimes as a U. Now let us consider here. This is how a water molecule vibrate. You can see here the hydrogen and the oxygen. The central red colored ball is oxygen, and the periphery lateral two are the hydrogen. They are having continuous vibration motion, and this vibration motion gives energy to that. This is with respect to the water molecule. What about the NaCl? This is a liquid. What about the NaCl? NaCl looks like this. There is a continuous motion of the molecule, vibration, rotation, translation, due to which there is a cumulative energy which is called as the internal energy. और ये मॉलिक्यूल्स जो है ये हमेशा आपको वाइब्रेट करते हुए दिखेंगे, हमेशा आपको ट्रांसलेट होते हुए दिखेंगे, हमेशा उसको रोटेशन होते रहेगा। ये सभी मोशंस जो है, ये मोशंस उसको एक एनर्जी देते हैं जिसको कहा जाता है इंटरनल एनर्जी। नाउ लेट्स सी, जैसे कि मैंने आपको एग्जांपल दिया कि एक पेपर जो है वो बर्न होते समय हमको किस तरह से चेंजेस दिखाता है। कंसिडर a system where the particles are moving with a very small speed, with a very small space at a low temperature. If I shift this system by increasing the temperature, it it vibrates with a faster speed. Means there is a relation of temperature with the kinetic energy or the energy of that system, because it increases the motion of the molecule. And mathematically, the internal energy of ideal gas is directly proportional to temperature, which can be equated with the equation energy of system is 3/2 into RT. अगर यहाँ पे हम समझते हैं, ये अगर 3/2 कांस्टेंट है और R गैस कांस्टेंट है, तो यहाँ पे रिलेशन ये बनता है एनर्जी ऑफ सिस्टम इज डायरेक्टली प्रोपोर्शनल टेम्परेचर. If we increase the temperature, the energy of the system increases. If you decrease the temperature, energy of the system decreases. Means if I increase the temperature of a gas, this will look like this, because all the molecule have enough energy to move around, because the temperature increases the kinetic energy. Now next important parameter is entropy. Now see student, entropy, we can see the entropy as one of the driving force for any process. Means by looking at the entropy you can identify the process. By looking at the entropy you can suggest whether the process is feasible or not. और ये एंट्रोपी हमको एक इंडिकेशन देता है कि ये प्रोसेस आगे जाके होगा या नहीं होगा. इट कैन प्रिडिक्ट द प्रोसेस. It is the measure of disorderness and unavailable energy in a closed system. Now, what is the meaning of the disorderness? Consider a, a crystal of NaCl. As you have learned in your physics as well as in the chemistry, in the crystalletics, NaCl is one of the most, not the most, it is one of the most systematically arranged molecule. Means all the atoms are placed with an equal distance. So this is a orderedness. But if we consider a gas, the molecules are randomly moving around. This is disorderness. इसको मैं एग्जांपल देता हूँ. जैसे कि हमारे 3 क्लास के बाद एक ब्रेक होता है, रेसेस कहते हैं हम उसको. तो मैम का क्लास चालू है, तो ऑब्वियसली मैम इतना अच्छा पढ़ाते हैं कि वहाँ पे सभी बच्चे पूरे फोकस के साथ वो क्लास को पूरा पे अटेंशन करते हैं. तो स्टूडेंट्स आर इन अ identical position, sitting on the desk benches, looking at the blackboard, understanding the thing in a very identical way, in a very ordered way. But after the class, when madam left the classroom and there is a recess, क्या स्टूडेंट वैसे ही बाहर निकलते हैं क्लासरूम से? नहीं. दे विल रश टू द out of the class to visit their another faculty or to visit certain college purposes, to have their food, to meet their friends from the other. Now the system becomes disorder. Means when the molecules are arranged in a ordered way, it is having a certain behavior. But when the order is disturbed, it converts to disorderness. This is taken care by the parameter that is entropy. Okay, disorderness is being studied with the entropy. It varies directly with the reversible changes and inversely with the temperature. What is the meaning of this? It varies reversibly directly with the reversibly change in the system. Means it is having a relation with the system's heat. Heat is one of the form of energy, and it is inversely proportional to the temperature. That means if we decrease the temperature, entropy decreases. इसका एग्जाम्पल अगले स्लाइड में मैं उसको और एक बार एलॉबरेट करूंगा. So it is related with the heat and it is related with the temperature. It varies reversely with the heat and inversely with the temperature. And this is the symbol used for change of the entropy. It is very difficult or it is not possible to determine the entropy of a material, but I can change the system, the entropy of the material changes, and I can determine the delta S, that is a change of entropy of the system. नाउ लेट्स टेक द एग्जांपल. ठीक है, तो यहाँ पे आप देख सकते हैं कि एंट्रोपी, जैसे कि हमारे पास जो वाटर मॉलिक्यूल है H2O. ओके, नाउ दिस H2O is available in three forms: solid, liquid and gas. In the solid, they are most properly arranged, they form solid, means it is ordered in nature, entropy less. When we hit the ice, or if we keep this ice at the temperature of 30 degrees Celsius, it will naturally melt down to form the liquid. Now the intermolecular forces becomes weak and the molecule are randomly arranged. Entropy increases. And when this water is heated at 100 degrees Celsius, which increases the gas water temperature to more than 100 degrees Celsius, is converted to the vapor state. At this stage, the molecules are separated apart. More disorderedness, more entropy. So, in ice, more orderness, less entropy. In water, moderate orderness, moderate entropy. In gas, less orderness, more entropy. So, we can have a simple relation that entropy is directly proportional to the disorderness, or entropy is inversely proportional to the orderness. More ordered molecule, less entropy; less ordered molecule, more entropy. Now the free energy. This free energy is a third thermodynamic function. It is important because it is required to understand the equilibrium of a system as well as the feasibility of a system. अगर आपको फ्री एनर्जी का साइन पता है तो आप आइडेंटिफाई कर सकते हैं कि प्रोसेस कितना आगे जाएगा या वहीं पे वो रुकेगा या इक्विलिब्रियम में है. जैसे ये दो फॉर्म्स में हम लोग देखने वाले हैं. वन इज हेल्मोट्स गिब्स फ्री एनर्जी and next one is Gibbs free energy. These are the forms of the free energy. Okay, these are the forms of the free energy, and this is associated with certain parameter that is having direct relation with the equilibrium and the feasibility. Take the first one, Helmholtz free energy. It is also called as work function. It is determined by internal energy and the temperature entropy change of the process. It is given by F is equals to U minus Ts. F is a Helmholtz free energy. U is the internal energy minus temperature entropy change of the process. Temperature entropy change of the process. And the Gibbs free energy is determined by enthalpy, temperature entropy changes. So if we take the both formulas, that is Helmholtz free energy and the Gibbs free energy, though this goes in hand, almost दोनों सेम लगते हैं, लेकिन दोनों में एक डिफरेंस है. In case of Helmholtz free energy, there is internal energy, whereas in case of enthalpy, there is Gibbs free there is a enthalpy. इसको याद कैसे रखें? हेल्मोट्स इंटरनल एनर्जी, गिब्स एंथैल्पी. ठीक है, हम लोग आगे देखेंगे इंटरनल एनर्जी और एंथैल्पी में क्या रिलेशन है. बाकी इफ यू कंसीडर दिस F is equals to U minus Ts and G is equals to H minus Ts, F and G are the free energies. F is Helmholtz free energy and G is Gibbs free energy. U is the internal energy, H is the enthalpy and temperature and the entropy. Okay, now Suppose now we will see what are the different conditions that we can understand. Consider a condition where no work is done by the system on the surrounding or vice versa. During this chemical reaction, whatever the change is there is the internal energy of system. Means under this condition, whatever heat given or absorbed by the system is equals to change of internal energy of the system. For example, अगर हम लोग एक रिएक्शन ले रहे हैं, इस रिएक्शन में किसी भी तरह का वर्क डन नहीं हो रहा है, यानी ना सिस्टम सराउंडिंग के ऊपर वर्क कर रहा है, ना सराउंडिंग सिस्टम के ऊपर वर्क कर रहा है, तो इस केस में जो भी हम लोग हीट देते हैं या वहाँ से हीट लेते हैं, ये उस इंटरनल एनर्जी का सिस्टम में चेंज होता है. अब इसको समझे कैसे कैसे विजुलाइज करें. सपोज हमारे पास एक बलून है. बलून को जब हम लोग ब्लो करते हैं तो उसका वॉल्यूम बढ़ता है. तो इस बलून को हम लोग कहते हैं सिस्टम, और जिसके अंदर वो स्टडी हो रहा है वो है सराउंडिंग. व्हेन वी ब्लो द एयर इन द बलून, the volume increases. In this case, the work is done by the system on the surrounding. Are you getting the difference? When I blow the balloon, air increases the volume of the balloon, means its size increases, due to which the balloon volume increases and it work on the surrounding. In other way around, if surrounding gives pressure to the balloon and the air is been released, surrounding work on the system. In this case, if no such type of work is done, अगर किसी भी तरह का वर्क डन नहीं हो रहा, वर्क डन यानी क्या, प्रेशर वॉल्यूम. ओके, आपके प्रेशर देने से वॉल्यूम में चेंज होना, इट इज कॉल्ड एज द वर्क डन. पीडीवी इज द वर्क डन. अगर कुछ ऐसा प्रोसेस है जहाँ पे वर्क डन नहीं हो रहा है और सिस्टम और सराउंडिंग जो है इसमें कोई भी वर्क डन नहीं हो रहा है, तो जितना भी आप हीट दे रहे हैं वो उसके इंटरनल एनर्जी में चेंज होता है. ये मुझे कन्वे करना था. दैट इज द टोटल चेंज ऑफ द सिस्टम इज नथिंग बट द हीट एब्जॉर्ब or given by the heat when W is zero. W is zero means work is zero. जब ना सिस्टम सराउंडिंग के ऊपर वर्क करता है या ना सराउंडिंग सिस्टम के ऊपर वर्क करता है, उस केस में जितना भी आप हीट दोगे या हीट रिलीज करोगे या गेन करोगे, वो उस इंटरनल एनर्जी का हिस्सा बनेगा. Now another way, at constant volume, when heat is given off or absorbed, the change in the internal energy is given by the constant. Again, अगर आपने वॉल्यूम कांस्टेंट रखा है, ठीक है, तो जितना भी हीट वहाँ पे ट्रांजिशन हो रहा है, आइदर यू आर गिविंग द हीट और टेकिंग द हीट, the change will be given as the internal energy at constant volume. Now suppose देर इज अ इन्फ्लुएंस बिटवीन सिस्टम सराउंडिंग, और जैसे मैंने बोला कंसिडर अ सिस्टम एंड सराउंडिंग, देर इज इन्फ्लुएंस ऑफ ईच अदर. और जब मैं वहाँ पे सिस्टम और सराउंडिंग का एक इंटरेक्शन देखता हूँ, दैट मीन्स सर्टन वर्क इज डन बाय द सिस्टम और बाय द सराउंडिंग. means if system perform work on the system or vice versa, the change in this consideration will be sum of two things. These are work done by वर्क डन एंड द हीट. ऑब्वियसली जब तक वॉल्यूम चेंज नहीं हो रहा था, जो भी इंटरनल एनर्जी था वो हीट के ऊपर डिपेंड था. जैसे ही वहाँ पे वर्क इन्वॉल्व हुआ वो सम हो गया. सो चेंज ऑफ इंटरनल एनर्जी ऑफ द सिस्टम इज इक्वल्स टू क्यू, दैट इज अ हीट चेंज और द हीट एंड द वर्क. ओके, मीन्स जैसे ही वहाँ पे वर्क होगा, वर्क का आपको यहाँ पे कंट्रीब्यूशन दिखेगा. चेंज ऑफ द energy, internal energy of system becomes equals to the heat provided or taken plus work done or work given. Now इसको एलाबोरेट करते हैं तो हम लोग यहाँ तक जाएंगे कि अगर हम लोग एंथैल्पी का कॉन्सेप्ट यहाँ पे इंट्रोड्यूस करते हैं, इट इज अ सम ऑफ सिस्टम्स एनर्जी प्लस वर्क डन. मीन्स either heat is given or taken, the enthalpy is the sum of internal energy plus work done. इंटरनल एनर्जी प्लस वर्क डन. तो यहाँ पे इंटरनल एनर्जी जो है वो सिस्टम का डिपेंड करता है कि आपने वॉल्यूम और प्रेशर पे वर्क किया है क्या नहीं किया है। जैसे कि अगर मैं थोड़ा सा इसको सामने रखते हुए अगर मैं डिस्कस करूं, तो एंथैल्पी और इंटरनल एनर्जी किस तरह से आइडेंटिफाई किया जाए। इंटरनल एनर्जी इज नथिंग बट क्वांटिटी ऑफ हीट टेकन और एब्जॉर्ब बाय द सिस्टम with constant volume or pressure. If it is that case, whatever the heat absorbed or the gain is its internal energy. But when a system work on the surrounding or surrounding work on the system, there is a change of the pressure volume work. It is called work. For that case, internal energy is equals to E plus equals to Q plus W. Internal energy equals to Q plus W. बट व्हेन देर इज अ चेंज इन द वॉल्यूम एंड प्रेशर, यानी वहां पे वॉल्यूम और प्रेशर में चेंज हो रहा है, तो उस केस में वर्क डन भी हो रहा है, तब हम उसको कहते हैं एंथैल्पी। एंथैल्पी ऑफ द सिस्टम इक्वल्स टू एंथैल्पी ऑफ द सिस्टम प्लस पीवी। इंटरनल एनर्जी के समय क्या था, इंटरनल एनर्जी इक्वल्स टू क्यू प्लस डब्ल्यू। W is the work, PV is also work. The heat given or absorbed during a chemical reaction at constant pressure is equals to change in the enthalpy of the system. अगर constant pressure या volume रखेंगे तो obviously आपका वहाँ पे heat change consider होगा। Okay, this is the summary. This is a summary. मैं ये इतना अगर आप माइंड फ्रेम में रखते हो तो मैं इसको इजीली एक्सप्लेन करता हूँ। सपोज आपने हीट ट्रांजिशन दी, हीट गिवन और टेकन, और वहां पे वॉल्यूम कांस्टेंट है, तो इंटरनल एनर्जी इक्वल्स टू हीट ऑफ दैट वॉल्यूम। सिमिलरली व्हेन the heat is given or absorbed at constant pressure, it becomes enthalpy. Enthalpy of system equals to qp. And when the both pressure and the volume are having certain value and there is a work, then enthalpy of the system equals to change of the energy plus change in pv work. Now the last but one part of the session, the need of second law of thermodynamics. Now why it is important to study the second law of thermodynamics in a more detailed way. The first law suggested that we can convert one form of energy to the another form of energy, and the energy of a universe is constant। यानी हम लोग देखते हैं कि फर्स्ट लॉ एक बेसिक लॉ बनता है, बहुत ही ट्रेडिशनल क्लासिकल लॉ है, और ये कहता है कि आप एक फॉर्म से दूसरे फॉर्म में जा सकते हैं, एक एनर्जी दूसरे एनर्जी में कन्वर्ट हो सकता है, और एनर्जी को ना हम क्रिएट कर सकते ना डिस्ट्रॉय कर सकते हैं। वी कैन नॉट क्रिएट energy or we cannot destroy the energy, but it converts from one form to another। For example, uh, when we are when we are switching on the ceiling fan button, the electricity runs there, and due to that electromagnetic motion, the ceiling fan runs, so electrical energy is converted to the kinetic energy। Second example, suppose you are living at the fourth floor of the building and you are having certain water tank. To bring water from ground level to the fourth floor, we will use certain pump। Now by using this pump, I can take the water to a fourth floor। Okay, means I use the electrical energy to take this water to a higher level, but when this uh, water reach at the highest altitude, that is fourth floor, it will have a certain property, that is potential energy। ओके, और अदर वे अराउंड हम लोगों ने जो डैम देखते हैं, हाइड्रो इलेक्ट्रिक जो एनर्जी फॉर्म करते हैं, प्रिपेयर करते हैं, वहाँ क्या होता है, डैम से जब हम लोग कंटिन्यूसली हाई स्पीड में वाटर को फ्लो करते हैं, टर्बाइंस को रन करता है, पोटेंशियल एनर्जी इज कन्वर्टेड टू द काइनेटिक एनर्जी, एंड काइनेटिक एनर्जी इज कन्वर्टेड टू रन द टर्बाइन टू द इलेक्ट्रिसिटी। बट देयर आर सर्टन लिमिटेशंस। ये लिमिटेशंस क्या थे जिसके वजह से हमको सेकंड लॉ की तरफ जाना पड़ा। दिस लिमिटेशंस आर, first law does not give any restriction on the extent and the condition in which conversion of energy takes place। यानी इसने कहीं रिस्ट्रिक्शन नहीं दिया कि कितने लेवल तक वो कन्वर्ट कर पाएगा, 100%, 20%, 80%। इट डज नॉट गिव्स एनी रिस्ट्रिक्शन, जस्ट इट सेड दैट one form of energy is converted to the another, but how much quantity, 10% conversion होगा, 50% conversion होगा, it does not explain by the first law. Similarly, it does not give the information about the feasibility of the process. Feasibility of the process means whether the process uh, is possible or not. ओके, ऐसा तो नहीं है कि आप कुछ भी दो ऐड कर देंगे तो आपको सी मिलेगा, ए प्लस बी इक्वल्स टू सी. ओके, देयर शुड बी सर्टन कंडीशंस, और वो कंडीशंस ही डिसाइड करते हैं कि वो प्रोसेस आगे बढ़ेगा या नहीं बढ़ेगा, विच इज कॉल्ड एज द फिजिबिलिटी. एंड इन अ मोर कन्वेंशनल लैंग्वेज इट इज कॉल्ड एज द पॉसिबिलिटी. मीन्स वेदर द process is possible or not, it is not given by the first law. Then it does not suggest the condition for the conversion. ना उसने रिस्ट्रिक्शन रखा एक्सटेंशन पर, ना उसने कंडीशन रखा, बस उसने कहा कि एक एनर्जी दूसरे एनर्जी में कन्वर्ट हो सकता है. एंड लास्ट, यहाँ पे उन्होंने कन्वर्शन के तौर पे जो एक मिथ है हीट इंजन का, वो एक्सप्लेन नहीं कर पाए. इट फेल्स टू द एग्जिस्टेंस ऑफ 100% efficient heat engine. यानी as far as first law is concerned, they suggested that 100% of one form of energy is converted to the 100% of another form of energy, means 100% conversion. But this is not possible practically. This is not suggested by the second law of thermodynamics. So what is the need of second law of thermodynamics? Because first law does not give any restriction on the extent and condition of the interconversion. It does not give information about the feasibility or the possibility of the process. It does not tells the condition in which conversion is possible, and it fails to justify the 100% conversion, because 100% conversion of any form of energy to the another form of energy is not possible in actual condition. Now let us see the example. So first one, it does not suggest it the extent of one form to another form of energy is not possible. ओके, ये जो उसने कहा था फर्स्ट लॉ, ये एक्सप्लेन नहीं किया है. जैसे कि फॉर एग्जांपल ये हम लोग देखते हैं. देखिए यहाँ पे, इफ यू सी हियर, द वन फॉर्म ऑफ एनर्जी इज कन्वर्टेड टू द अनदर फॉर्म ऑफ एनर्जी. फर्स्ट वन बॉल goes to the bucket, it rolls on the ball, then it switch on the electricity to turn on the fan, and this turn on fan flows the cloth. Now, all this conversion means one form to another form is suggested by the first law. But what is the extent? कितने extent तक वो convert करेगा, ये वो नहीं बता पाया. Excuse me. In the same way, first law of thermodynamics do not tells us about the feasibility of process, whether the process is feasible or not, whether the reactant react to give product or not, whether the process is reversible, whether the process come back to zero. It is not suggested by the first law. We cannot get the clear information of the process of the feasibility by using the first law. वो इसका information ही नहीं देता. Third one, 100% conversion of energy to the work. Okay, if we go with the change of the one form of energy to the another form of energy, it is suggested that complete conversion means 100% of one form to the other form, means 100% efficiency. Means if I convert energy to the work, 100% conversion, but actually if we consider the heat engine, it is not possible. We cannot have 100% efficient engine with respect to the first law of thermodynamics. And the last one, डायरेक्शन ऑफ द प्रोसेस. हमको ये सिर्फ इतना बोल रहा है कि एक फॉर्म से दूसरे फॉर्म में जा सकता है, लेकिन उसका डायरेक्शन वो नहीं बताता. ओनली वन फॉर्म ऑफ एनर्जी इज कन्वर्टेड टू द अनदर फॉर्म ऑफ एनर्जी, यानी this direction is also not given by this one. For example, if you take a metal rod and it is heated, the first end will be heated first, like this, then the second one, and the third one. This is the natural phenomena, means temperature always flow from higher temperature to the lower temperature. It cannot flow from lower temperature to the higher temperature. So this direction is not suggested by the first law of thermodynamics. So, due to these four factors, first law does not tells us the extent of one form of energy to the another form of energy. It does not tells us feasibility of the process. It does not tells us the 100% conversion of one form to another or conversion of 100% energy to the work, and it does not tells us the flow of the process from where it should go and what will be the route. It is not given by the first law of thermodynamics. That's why it gives us the concept of second law. It is required, second law is required to explain the reversible process and the spontaneous process. Now, as the word suggested, a reversible process is one that can proceed in either direction with equal ease. Means a plus b equals to c is possible, and also possible c gives to a plus b. Means it can go forward, it can go backward. So these processes are called as the reversible process. But the spontaneous processes are unidirectional and irreversible, and all the natural processes are spontaneous processes. You will not find a mango coming down from the tree to the ground. This will be the unidirectional, but you will not find this mango again goes back to the tree, or a ball which is thrown upward will goes upward till the gravity, but when gravity overpowers it will come down, it will not go extend to that. Means the processes which are spontaneous are unidirectional and irreversible. ओके, इसको रिवर्सिबल हम लोग नहीं कर सकते हैं. देन नॉन स्पॉन्टेनियस प्रोसेसेस आर द वन विच डू नॉट अकोर itself. इट रिक्वायर्स अदर एक्सटर्नल एनर्जी. फॉर एग्जाम्पल, जैसे मैंने आपको कहा, अगर आपका घर फोर्थ फ्लोर पे है, वहाँ पे आपको ग्राउंड फ्लोर से फोर्थ फ्लोर में वाटर ले जाना है, तो क्या वाटर अपने आप ऊपर जाएगा? नहीं. दैट रिक्वायर्ड मोटर. That motor will use electricity and will pump it down to the fourth floor. These processes are called as the non-spontaneous processes. These are also called as the artificial processes because they do not carry down with their own, but spontaneous processes are carried on. मैंने फोर्थ फ्लोर पे टंकी भर लिया है, बट जैसे ही मैं टंकी ऑन करूंगा वो नेचुरली नीचे आता है बिकॉज द पोटेंशियल एनर्जी कन्वर्ट्स टू द काइनेटिक एनर्जी. दीज आर द स्पॉन्टेनियस processes. Now, these are the various statements of the second law of thermodynamics. Okay, और यूनिवर्सिटी एग्जामिनेशन में इसके स्टेटमेंट्स भी पूछे जाते हैं. Kelvin Planck statement. It is impossible to convert heat into work completely by the cyclic process without producing change in some part of system. देखिए, केल्विन प्लैंक का स्टेटमेंट ये कहता है कि कंप्लीट कन्वर्शन ऑफ हीट और वर्क पॉसिबल नहीं है जब तक उसमें कुछ चेंजेस ना किया जाए. Cauchy statement. For a self-acting machine, it is impossible to transfer heat from body at lower temperature to a body at higher temperature without any external assistance or without some same time converting work and heat. यानी एक लोअर टेम्परेचर टू हायर टेम्परेचर नहीं जा सकते हैं और इसके लिए आपको एक कुछ चेंजेस करने पड़ेंगे. Third one, Thomson statement. A continuous supply of work cannot be obtained by cooling a body to a temperature lower than its surrounding. Obviously, क्योंकि जो एनर्जी है वो हमेशा हायर टू लोअर जाता है, लोअर टू हायर नहीं जाता है, तो उससे वर्क नहीं हो सकता. इट इज द कंक्लूजन ऑफ द थॉमस स्टेटमेंट. Now, the last topic of today's session, role of role of Gibbs free energy, why it is important and where it plays important role. It is important to suggest whether the process is possible or not, feasible or not, whether the process goes with the equilibrium or not. ये सब डिसाइड करने के लिए we need Gibbs free energy. Now, how we relate this Gibbs free energy with respect to the process? It is taken care by the chemical equilibrium and the oxidation reduction. Means Gibbs free energy has is having an important relation with the chemical equilibrium and oxidation reduction. Let's take first chemical equilibrium. As the word equilibrium, it is a state of the process where the forward and the backward can have same effect. It is a process, it is a stage at which reactant can convert to product or product can revert back to the reactant. The direction of chemical reaction in the condition of constant temperature and pressure is decided by decrease in the Gibbs free energy. Means if a process is having negative Gibbs free energy, the direction is feasible. Means the reaction is going in a proper way and it is feasible. In natural process, Gibbs energy becomes more negative during the process and it cannot be positive. यानी जितने भी नेचुरल प्रोसेसेस है वहाँ पे आपको गिब्स फ्री एनर्जी नेगेटिव मिलेगा. किसी भी केमिकल प्रोसेस का जो नेचुरल नहीं है यानी जो नेचुरल है वो कभी पॉजिटिव नहीं हो सकता. Like this, see how the equilibrium is achieved. First, reactant AB and product CD. Now, if there is an equilibrium, this CD again converts to AB. Means at the AB we will have 4 and at the CD we will have 4. 4 and 4 it is the equilibrium. This is given by chemical equilibrium and if the process is feasible यानी अगर वो रिएक्टेंट प्रोडक्ट में कन्वर्ट करना चाहता है तो डेल्टा जी या जी का वैल्यू निगेटिव में होना ज़रूरी है और ये हमको इन्फॉर्मेशन देता है केमिकल इक्विलिब्रियम. And the last topic of the day, reduction potential. Now what is reduction and what is oxidation? Oxidation is a loss of electron, reduction is a gain of electron. This is also decided by the Gibbs free energy, whether the Gibbs free energy is having negative value or positive value, and this phenomena is used for the calculation of the electrode potential of the cell or the electrode. The change in quantity of free energy and change in the quantity of reduction potential are related with the equation. These are related with the spontaneity by this equation. Delta G0 equals to minus NF delta E0. Okay. Now delta G0 is a Gibbs free energy change. N is the number of electron involved. F is the Faraday constant and delta E is the reduction potential. Okay. Now by knowing whether the delta G value sign is positive or negative, we can suggest whether the reaction is oxidation, whether the reaction is reduction, and even this is used to calculate the EMF of an battery of a battery. Now at the last the summary what we learn in this online session. The first one is the thermodynamic terms. The thermodynamic terms like system, surrounding, universe, boundary, adiabatic boundary, dithermal boundary are being learned is discussed in this one. Then, then different thermodynamic functions. Functions because they changes with the process. Energy, entropy, and the Gibbs free energy. Then extensive and the intensive property. The property of the material or the system which changes with the quantity of the component is the extensive property. The property of the system which do not changes with the quantity of the component are called as the intensive property. Then second law of thermodynamics, we learn why second law of thermodynamics is important because first law do not explain the extent, it do not explain the 100% efficiency of engine, which is not possible. It do not gives the direction of the reaction or the process and it do not gives the extent, okay, of the conversion or the feasibility. Then reversible, irreversible, reversible processes can go from backward to forward, forward to backward, but irreversible processes are unidirectional. They are having a one direction, they cannot be reversed. And then Gibbs free energy. Gibbs free energy is important with respect to suggesting the process is feasible or not. It is being studied with two parameter, Gibbs free energy, Helmholtz free energy. So thank you so much for the patient listening. If somebody wants to have certain question in the forum, can ask. Can I escape the screen sharing, ma'am?
Yes, sir, you may. Yes, dear students, if you have any queries, any question, you may put it in the chat box. And in fact, sir will be very much happy to answer your queries. So, what
Anything
type
from
of
your side,
question
ma'am?
basic? What type
Yes,
of
ma'am.
question basically is being asked in university?
Okay, very nice question. The probable question generally asked in the university depend give the relation between enthalpy and the internal energy. There are certain uh, various features or the parameter on which the internal energy and the enthalpy relates. For example, as we have discussed, the system at constant volume. When a system has a constant volume, whatever the heat we provide, it converts to internal energy. When the system at constant pressure, whatever energy we provide, it converts to internal energy. That is, internal energy of system equals to qv or qp. But when the system changes with the with the volume and the pressure, the change of the internal energy converts to two parts. One is internal energy and one is work done, and this is taken care by the enthalpy. Then equation becomes h of the system equals to e plus pv. This is generally asked question. Give a relationship between internal energy and the enthalpy. Second one, what is the need of second law of thermodynamics? कि हम लोग सेकंड लॉ ऑफ थर्मोडायनेमिक्स क्यों इतना इंपॉर्टेंट है, तो आपको ये बताना होगा कि फर्स्ट लॉ ना एक्सटेंट बताता है, ना कन्वर्शन की एफिशिएंसी बताता है, ना वो 100% एफिशिएंट जो सजेस्ट करता है 100% कन्वर्शन ऑफ वन फॉर्म ऑफ एनर्जी टू द वर्क वो बताता है, या फिजिबिलिटी. As the first law do not explain this four parameter, we need to go to the second law of thermodynamics. And the third one, they may ask you about what is the difference between the extensive property and the intensive property. And by giving few example, you can elaborate that. Extensive property are those property of the system which changes with the quantity, whereas the intensive property are those properties of the system which do not changes with the quantity. And you have a good list of the intensive and the extensive property as I highlighted in the class. Like the volume is the extensive property, then the pressure is the extensive property, then temperature is the intensive property, density is the intensive property. You can remember one and two for the exam for the sake of example.
Okay, thank you so very much, sir. I suppose, sir, the students they don't have any questions. I couldn't see anyone asking. दो चीजें हो सकती हैं, या तो सारा चीज समझ गए या तो कुछ समझा ही नहीं. And I
Madam,
consider it a positive.
thermodynamics
I
is a topic. It took a lot of hours to learn, and it
learn.
took weeks to understand and to explain it. But no
Very
issue.
true.
I try to keep this in a nutshell so that students don't get bored in this class.
No, sir, I am taking a positive thing here that my student they must have understood. They just need some time to revise the thing so that they may have more questions. That is one of the
Okay.
thing. And let me propose the vote of thanks for this lovely, beautiful, interactive, I should say, session. The first thing is कि मुझे खुद को thermodynamics थोड़ा सा डर लगता है. So no doubt your explanation has boosted my morale as well. You know, as an analytical chemist, I can now feel confident in teaching thermodynamics to my student as well. As at the onset, just taking privilege in thanking you, sir. Indeed, you have taken time from your busy schedule and you have rendered your time to us. Thank you so very much. I'm thankful to the management of Anshuman College of Engineering and Technology, our beloved principal, our HOD. He's on leave, so I'm be taking charge of the HOD. Dr. Shahbaz Khan sir, Dr. Neetu Gupta ma'am, and all the class coordinator and the students, those who have directly and indirectly helped me out in conducting this guest lecture. Thank you so very much, sir, and
Thank
hope
you so
to
much,
join
madam.
for another guest lecture soon. Okay, thank you.
Anytime,
That's
ma'am.
all we
Anytime,
have.
ma'am. Thank you so much,
God
ma'am,
bless you.
for giving me this opportunity. to have interaction with so on this topic with the students. Thank you so much, ma'am, once again.
Thank you so much, sir. Okay, sir. Thank you. That's all we have, dear students. The link for the attendance and the feedback has been shared in the chat box, requesting you to kindly fill up the attendance and the feedback. Thank you. God bless you. Good day, sir.
Thank you so much, ma'am.